Maybe I should start making a Facebook account. Now I can keep in touch with all my non-existent friends. First name, last name, password. What is the most random password that no one will ever think of? Random numbers? But how do I generate it?
The oldest methods that you can find for generating random numbers are such as dice, coin flipping, bingos, and roulette wheels, which are still being used today, mainly in games and gambling, as they tend to be slow for most applications in statistics and cryptography. A physical random number generator can be based on an essentially random atomic or subatomic physical phenomenon whose unpredictability can be traced to the laws of quantum mechanics. Sources of entropy includes radioactive decay, thermal noise, short noise, avalanche noise in Zener diodes, clock drift, the timing of actual movements of a hard disk or write head, and radio noise. However, the physical phenomena and tools used to measure them generally features asymmetries and systematic bias that make their outcomes not uniformly random. A randomness extractor such as cryptographic hash function can be used to approach a uniform distribution of bits from a non-uniformly random source, though at a lower bit rate.
Various imaginative way of collecting this type of entropic information has been devised. One technique is to run hash function against the frame of a video stream from an unpredictable source. Lava was to be used with this technique with the image of the number of lava lamps. Hobbits measure radioactive decay with given Muller tubes, while random ORG used various variation in the amplitude of atmospheric noise and recorded with a normal radio. Another common entropy source is the behavior of human users of the system. While people are not considered good randomness generator upon request, they generate random behavior quite well in the context of playing mixed strategy games. Such security-related computer software requires the user to make a lengthy series of mouse movement or keyboard input to create a sufficient entropy needed to generate random number keys or to initialize pseudo-random numbers generators.
Today I'm going to explain how do computers generate random numbers. So computer generate random numbers for everything from cryptography to video games and gambling. So cryptography requires numbers that attackers can't guess. So we can't just use the same number over and over again. We want to generate these numbers in a very unpredictable way so that the hackers can't guess them. These random numbers are essential for secure encryption, whether you're encrypting your own files or just using an HTTP website on the internet. So there are two categories of random numbers. First is the true random numbers. The second one is the pseudo-random numbers, and the difference is important for this security of encryption system. So to generate a true random number, the computer measures some type of physical phenomenon that occurs outside the computer. For example, the computer could measure the radioactive decay of an atom according to quantum theory. So there's no way to know for sure when the radioactive decay will occur. So this is essential pure randomness from the universe. A hacker wouldn't be able to predict when radioactive decay would occur. So they wouldn't know that the random value. So for more examples, the computer could rely on atmospheric noise or simply use the exact time you press keys on your keyboard as a source of unpredictable data. For example, your computer might notice that you press a key at exactly, for example, 2 seconds after 2 p.m. Grab enough of the specific times associated with this key presses and you have a source of entropy you can use to generate a true random number. you're not a predictable machine, so a hacker can't guess the precise moment when you press the keys.
Talking about pseudo-random numbers. Pseudo-random numbers are an alternative to true random numbers. A computer could use a seed value and an algorithm to generate numbers that appear to be random, but that are in fact predictable. The computer doesn't gather any random data from the environment. This isn't necessarily a bad thing in every situation. For example, if you're playing a video game, it doesn't really matter whether the events that occur in the game are caused by true random numbers or pseudo-random numbers. On the other hand, if you're using an encryption, you don't want to use pseudo-random numbers to an attacker could guess. For example, let's say an attacker knows the algorithm and seed value a pseudo-random number generator uses. And let's say an encryption algorithm gets a pseudo-random number from this algorithm and uses it to generate an encryption key without adding any additional randomness. If an attacker knows enough, they could work backwards and determine the pseudo-random number the encryption algorithm must have chosen in the case, breaking the encryption. To generate true random numbers, random number generator gather entropy or seemingly random data from the physical world around them. For random numbers that don't really need to be random, they may just use an algorithm and a seed value.
I'm Mr. Sko, and I'm talking about generating random numbers through probability distribution. Other than physical and computational methods, we can achieve random numbers through probability distribution. Unlike the previous two methods which rely on physics and repeated algorithms, the probability distribution relies on a mathematical method called probability density function. The probability density function is a function that portrays the probability of a random variable to take on a given value. A simple explanation would be the use of normal distribution graphs. A normal distribution graph entails a uniform set of random numbers by a certain recognizable pattern. Probability distribution takes these values and then transforms them through differing methods to achieve true random numbers. Note that because of the nature of probability distribution to rely on uniform sets of random numbers, this method can generate true random numbers as well as pseudo-random numbers. One of the methods to transform uniform set of random numbers is the inversion method. The inverse method, as its name suggests, takes a uniform set of random numbers and integrate them to achieve a new area of normal distribution. Pseudo-random numbers are then generated by taking values between 0 and one of the new distributions. Another method, the acceptance and rejection method, makes use of two variables of x and y instead. We are more familiar with this method. This method studies the distribution graph and compares the value of x and y within the distribution area. When at random, chosen point x value is greater than y value, then the number is generated and as a true random number. If x is not bigger than y, the number is rejected and the algorithm repeats itself to get another true random number instead. Okay, I'm going to present how to generate random numbers by the acceptance rejection method. We use a normal distribution graph. Some are better, some are worse, but let's use this one. We know that for acceptance rejection method, the x value needs to be greater than the y value for the number to be taken as random number. For example, at x equals to 1 here, y here is around 2. This number will be rejected. At here, 2. Here will be y will be 1. This will be taken. The process, this algorithm continues until all the way to the end of the graph. We can get numbers along at 2, 6, 8, and if it goes on like this, as x keeps on getting greater than y because of a greater gradient, we will get repeating numbers. That's how acceptance and rejection method works.
One form of random number generation is by humans. Many scientists do not believe that the human brain is capable of generating random numbers, but tests were carried out with healthy adults where they were asked to generate and dictate random numbers, and the numbers were then tested for uniformity and independence, and the results suggest that humans can generate random numbers that are uniformly distributed, independent, of one another and unpredictable. Although human brains are said to be able to generate completely random numbers, our brain will somehow restrict the possibilities and predict the next number from what we've seen or heard.
Humans can also generate random numbers using a 6-faced die. On each roll, each number from 1 to 6 is equally likely to appear, and if we roll it many times, we may expect to see each of the 6 possibilities roughly 1/6 of the time. The numbers obtained can be put together to form a series of random numbers.
But it is possible, however, that if we roll the die 100 times, we can obtain number 1 each time. Regardless, each number is likely to show up on the 101st time. But that's not all. In an experiment done by an anonymous netizen, he or she found that when given a range of numbers from 1 to 10, humans tend to pick odd numbers over even numbers, especially the number 7. An explanation based on psychological research was that the number 1 and 10 are too predictable, which means we'll cut that off, and even numbers just don't seem very random. That leaves us with 3, 5, 7, and 9. 3 is too far front, and 9 is too far back, while the number 5 is actually in the middle, which makes it seem predictable. So that leaves us with 7. Though is it really random? We cannot truly determine whether random is really random because
Now no one would know my password.
Thank you for your pause, for your like, for your click ทำให้ฉันได้เจอเธอที่ดีๆ Thank you for your love, for your care, for your kind ทำให้ฉันได้มีไทม์ไลน์ที่สวยงาม